Hi, my name is Joanna and this is our Group 24 project demo. The idea behind the project is to have a virtual assistant to guide visitors instead of an actual employee. Our project with NTT Data is to create a 3D virtual assistant using main technologies such as natural language processing, facial recognition, 3D animation, and more.
This is our system architecture diagram. The majority of our application is hosted locally on a laptop. We use a Python application that is connected to the speaker and microphone of the laptop. Open source libraries such as GStream and PyAudio allow us to do this. The Alexa voice service SDK is used in this application to be able to authenticate the user's Amazon account and connect to the Amazon cloud using the user request recorded on the microphone. An open source keyword detection engine called Snowboy is used to detect when the keyword that we specify is said. Currently, we have set this to Alexa, but this can be changed to several pre-built models, and our client can also train their own models to use if they would like. But this will come with voice detection performance rollbacks. The user's voice is only sent to the Amazon services once the keyword is detected. Amazon services process the request using advanced natural language processing and semantic voice analysis to either return a response directly to the application and the user, or send it to the Alexa Skills Kit, which connects to the API endpoint. It also handles the connection with IoT devices using an Amazon account connected to them. The API is made using Fast API, which is a high-performance ASGI Python web framework for building APIs. It is hosted on a cloud VM, and the endpoint is deployed using Unicorn, which is a minimal server application interface. We registered a domain for our API and set up Let's Encrypt certificates so that our API could be hosted using HTTPS and a domain name. This makes our API as secure as possible, which is important when handling company information, and it also allows us to communicate with the Alexa Skills Kit. The endpoint has methods for the Alexa skill, which stores the company information in video, and has a WebSocket to allow communication between the AVS Python app and the Unity backend. Secure WebSocket sends messages to the Unity backend so that the avatar knows when a change in the application state has been made.
We implement the client side of the WebSocket in the avatar using an open source Unity WebSocket library, which establishes a connection to the server side on Play. We create and develop the 3D avatar using Unity, where we animate the avatar's gestures and animations using the Unity animator. For video playing, we create a transparent game object with a video player component attached to it. The video player component is active only when the front end receives a message to play a video. The video player then plays the MP4 video that is hosted on the server. Once the video has finished playing, the component is destroyed. We implemented the face tracking using OpenCV. We split the camera's viewpoint's width into 7 sections, and using OpenCV, we detect and calculate the center of the user's face. Using the center of the user's face, we then rotate the avatar according to the position of the face in the 7 sections. Here are the demo videos for each completed feature. Firstly, natural conversation and mouth animation.
Alexa, what's the weather like in London?
In London, United Kingdom, it's 13 degrees Celsius with clear skies and sun. Today, you can expect mostly sunny weather, with a high of 13 degrees and a low of 1 degree.
Next, we have face tracking. Next is playing videos.
Alexa, open Blue Assistant.
Hi, welcome to Blue, your personal lab assistant. How may I help you today?
Play a video about NTT Data.
Playing.
Here at NTT Data, we're building something amazing. And you'll grow as we grow.
Alexa,
Developing new skills.
tell Blue Assistant to pause the video.
And advancing your career as we...
Alexa, tell Blue Assistant to play the video.
deliver for our clients. Together, we challenge conventional wisdom to build new capabilities and sustainable change, creating amazing experiences that unleash the power of imagination.
Alexa, tell Blue Assistant to stop the video.
Next, we have lab or company information.
Alexa, tell me more about NTT Data in the insurance industry.
The insurance industry must constantly address new regulatory requirements whilst remaining relevant and responsive to customer needs. At NTT Data, we know this is a complex problem with a multiplicity of options, which is why our team of skilled consultants engage with an open mind.
Next we have IoT devices.
Alexa, turn off the kitchen light.
Okay.
Alexa, turn the kitchen light brightness to 50%.
Okay.
Alexa, turn the kitchen light to red.
Okay.
Next we have user configurability.
Okay, so now we'll show the configurability of the assistant. So we'll SSH into our API server. And first we change directories to the API code, and then access the company info JSON file using a text editor. And then here you can see all the information about NTT data already there. You can also add stuff like our own company. So for example, you can add something about Microsoft like this. So here we have an about section for company info, and then also a video on the automotive section of Microsoft, which is over here. So then we save this, and then we can go back to the server running, stop the server running, and then run the server again. And then let's see if this works with the avatar.
Alexa, open Blue Assistant.
Hi, welcome to Blue, your personal lab assistant. How may I help you today?
Play a video about Microsoft in the automotive industry.
Did you know that Microsoft is still doing business with car manufacturers? Sammy
Pause
from
the
the
video.
NTT team, Microsoft
Play the video.
Connected Vehicle Platform team, is here to tell us everything about what's going on there.
Stop the video. Alexa, ask Blue Assistant to tell me more about Microsoft.
The last few years, Microsoft has consistently transformed the way that people live, work, play, and connect through great technology.
Lastly, we have smooth and natural gestures. We have completed all of our must-have requirements, and half of our should-have requirements. We have quite a number of must-have requirements, but we are really proud to have been able to achieve them all. We did make significant progress on our uncompleted should and could-haves as well.